While there are many paths towards building a scalable and secure long-term blockchain ecosystem, it's looking like they are all building towards very similar futures. There's a high chance that block production will end up centralized. Hello and welcome to another episode of Ethereum in Depth, Ethereum made audible for you. It's Tuesday, and we're going to be reading another piece from the Web3 and Ethereum ecosystem. This one is called Endgame by Vitalik Buterin. Came out in December of 21, so really just 4 months ago. And we've been going a lot into why Web3 matters, and before that, proof of stake and rollups, what the merge is going to be. And this piece jumps into the future. What is the end game for Ethereum? Where do we see this all going? The future of a rollup-centric Ethereum with proof of stake, with sharding, with ZK snarks and starks. What happens? What are we thinking about? What are we focusing about? What matters to us? And that's what we're going to be reading today. But before diving in, I want to give a shout out to Alpe Audio. For those of you who don't know, Alpe Audio is my startup, Yoshua's, where we do audio courses in depth for professionals who need to learn topics in depth, but they don't have time. And so the only time they have is when they're commuting, at the gym, running errands. And that's why we do it in the go through audio. In Alpe Audio, you can find all kinds of courses from marketing to everyday mindfulness, creative thinking, with the goal of helping you master those topics from A to Z in the time that you have. Every lesson comes with a summary, chapters, flashcards, additional resources that you can dive into. Really, it was kind of the podcasting app that I wished I had, and that's why I set out to build it. And Alpe Audio is user-supported, and Ethereum Audible is user-supported by helping out Alpe Audio. So thanks a lot. And with that, we're going to dive into The Endgame by Vitalik Buterin. Let's go. Consider the average big blockchain. Very high frequency blocks, very high block size, many thousands of transactions per second, but also highly centralized. Because the blocks are so big, only a few dozen or few hundred nodes can afford to run a fully participating node that can create blocks or verify the existing chain. What would it take to make such a chain acceptably truthless and censorship resistant, at least by my standards? Here is a plausible roadmap. 1. Add a second tier of staking with low resource requirements to do distributed block validation. The transactions in a block are split into 100 buckets, with a Merkle or Verkle tree state root after each bucket. Each second tier staker gets randomly assigned to one of the buckets. A block is only accepted when at least 2/3 of the validators assigned to each bucket sign off on it. 2. Introduce either fraud proofs or ZK snarks to let users directly and cheaply check block validity. ZK snarks can cryptographically prove block validity directly. Fraud proofs are a simpler scheme, where if a block has an invalid bucket, anyone can broadcast a fraud proof of just that bucket. This provides another layer of security on top of the randomly assigned validators. 3. Introduce data availability sampling to let users check block availability. By using data availability sampling checks, light clients can verify that a block was published by only downloading a few randomly selected pieces. 4. Add secondary transaction channels to prevent censorship. One way to do this is to allow secondary stakers to submit lists of transactions which the next main block must include. What we do get after all of this is done, we get a chain where block production is still centralized, but block validation is trustless and highly decentralized, and specialized anti-censorship magic prevents the block producers from censoring. It's somewhat aesthetically ugly, but it does provide the basic guarantees that we are looking for. Even if every single one of the primary stakers, which are the block producers, is intent on attacking or censoring, the worst that they could do is all go offline entirely, at which point the chain stops accepting transactions until the community pools their resources and sets up one primary staker node that is honest. Now, Consider one possible long-term future for rollups. Imagine that one particular rollup, whether Arbitrum, Optimism, ZK Sync, StarkNet, or something completely new, does a really good job of engineering their node implementation to the point where it really can do 10,000 transactions per second if given powerful enough hardware. The techniques for doing this are in principle well known, and implementations were made by Dan Larimer and others many years ago. Split up execution into one CPU thread running the unparallelizable but cheap business logic, and a huge number of other threads running the expensive but highly parallelizable cryptography. Imagine also that Ethereum implements sharding with data availability sampling and has the space to store that rollup's on-chain data between its 64 shards. As a result, everyone migrates to this rollup. What would that world look like? Once again, we get a world where block production is centralized, block validation is trustless and highly decentralized, and censorship is still prevented. Rollup block producers have to process a high number of transactions, and so does a difficult market to enter, but they have no way to push invalid blocks through. Block availability is secured by the underlying chain, and block validity is guaranteed by the rollup logic. If it's a ZK rollup, it's ensured by snarks, and an optimistic rollup is secure as long as there is one honest actor somewhere running a fraud prover node. Furthermore, because users always have the option of submitting transactions through the on-chain secondary inclusion channel, rollup sequencers also cannot effectively censor. Now, consider the other possible long-term future for rollups. No single rollup succeeds at holding anywhere close to the majority of Ethereum activity. Instead, they all top out at a few hundred transactions per second. We get a multi-rollup future for Ethereum, the Cosmos multi-chain vision, but on top of a base layer providing data availability and shared security. Users frequently rely on cross-rollup bridging to jump between different rollups without paying the high fees on the main chain. What would that world look like? It seems like we could have it all: decentralized validation, robust censorship resistance, and even distributed block production, because the rollups are all individually small and so easy to start producing blocks in. But the decentralization of block production may not last because of the possibility of cross-domain MEV. MEV is minor extractable value or maximum extractable value. There are a number of benefits to being able to construct the next block on many domains at the same time. You can create blocks that use arbitrage opportunities that rely on making transactions in two rollups, or one rollup and the main chain, or even more complex combinations. Hence, in a multi-domain world, there are strong pressures towards the same people controlling block production on all domains. It may not happen, but there's a good chance that it will, and we have to be prepared for that possibility. What can we do about it? So far, the best that we know how to do is to use two techniques in combination. The first is rollups implement some mechanism for auctioning off block production at each slot, or the Ethereum base layer implements proposer or builder separation. This ensures that at least any centralization tendencies in block production don't lead to a completely elite captured and concentrated staking pool market dominating block validation. The second is that rollups implement censorship resistant bypass channels, and the Ethereum base layer implements PBS, as in proposer builder separation, anti-censorship techniques. This ensures that if the winners of the potentially highly centralized pure block production market try to censor transactions, there are ways to bypass the censorship. So what's the result? Block production is centralized, block validation is trustless and highly decentralized, and censorship is still prevented. So what does this mean? While there are many paths towards building a scalable and secure long-term blockchain ecosystem, it's looking like they are all building towards very similar futures. There's a high chance that block production will end up centralized. Either the network effects within rollups or the network effects of cross-domain MEV push us in that direction in their own different ways. But what we can do is use a protocol-level techniques such as committee validation, data availability sampling, and bypass channels to regulate this market, ensuring that the winners cannot abuse their power. What does this mean for block producers? Block production is likely to become a specialized market and the domain expertise is likely to carry over across different domains. 90% of what makes a good optimism block producer also makes a good Arbitrum block producer, and a good Polygon block producer, and even a good Ethereum base layer block producer. If there are many domains, cross-domain arbitrage may also become an important source of revenue. What does this mean for Ethereum? First of all, Ethereum is very well positioned to adjust to this future world, despite the inherent uncertainty. The profound benefit of the Ethereum rollup-centric roadmap is that it means that Ethereum is open to all of the futures, and does not have to commit to an option about which one will necessarily win. Will users very strongly want to be on a single rollup? Ethereum, following its existing course, can be the base layer of that, automatically providing the anti-fraud and anti-censorship armor that high-capacity domains need to be secure. Is making a high-capacity domain too technically complicated, or do users just have a great need for variety? Ethereum can be the base layer of that too, and a very good one, as the common root of trust makes it far easier to move assets between rollups safely and cheaply. But also, Ethereum researchers should think hard about what levels of decentralization and block production are actually achievable. It may not be worth it to add complicated plumbing to make highly decentralized block production easy if cross-chain MEV, or even cross-shard MEV from one rollup taking up multiple shards, make it unsustainable regardless. What does this mean for big blockchains? There is a path for them to turn into something trustless and censorship resistant, and we'll soon find out if their core developers and communities actually value censorship resistance and decentralization enough for them to do it. It will likely take years for all of this to play out. Sharding and data availability sampling are complex technologies to implement. It will take years of refinement and audits for people to be fully comfortable storing their assets in a ZK rollup running a full EVM. And cross-domain MEV research, too, is still in its infancy. But it does look increasingly clear how a realistic but bright future for scalable blockchains is likely to emerge. Alright, and that was Vitalik Buterin's Endgame, which he wrote just 3 months ago. And it's not the kind of endgame that I was expecting when I heard that Vitalik had published this post on the endgame. I was expecting something a little bit more Pollyannish, a little bit more rosy. We'll all make it and it'll be great and we'll have scalability and we'll have rollups and shards and things like that. But like a lot of Vitalik's posts, these are a little bit more nuanced, and you have to understand the intricacies of what he's talking about. There are layers of concepts built on layers. I hope by now that you've got a good idea of a lot of those concepts, whether they're rollups and optimism, Arbitrum, ZK snarks, sharding. We've discussed all of that over the past 19 episodes. But I'd like to kind of take this from the ground up in terms of what I think Vitalik's main goal here and what really concerns him. And that is with decentralization and what that means and how you define decentralization. And we spoke about why decentralization matters over the past 3 different episodes in terms of what it enables and what you can build on top of it reliably. And so it all comes down to, how do you define decentralization? What are the metrics that we care about? And this is really the crux of the kind of debate between the big blockchains like Solana and the smaller blockchains. I mean, it's funny to call Ethereum a smaller blockchain, but Ethereum and definitely Bitcoin. And it comes down to a few key factors, and they are being able to run a node that validates the network. So policing yourself and making sure that what you're signing and that what people are sending you is valid. The second factor is who produces those blocks that you're signing, that you're validating. How many people are they? How widely distributed are they? Can they be censored or controlled? And the third one is really censorship resistance, which is, can those people who are producing blocks, can they censor transactions? Can they censor people? So you've got these 3 key metrics, right? Which is 1, I as a user. Can I see the rules of the game? Do I have control over the rules of the game? If someone sends me a Bitcoin transaction, can I validate that it's true? Can I validate that they're playing by the rules? Do I have enough storage and bandwidth on my own personal computer to know? Or do I not? Do I have to trust some server somewhere? That's issue number one. Issue number two is, how centralized are the block producers? Can I mine Bitcoin? Can I mine Ethereum or Solana? And if I can't, or if I can, who are those people who are mining, creating blocks? How widely distributed are they? How easy is it for regulation, or just in general, different organizations to clamp down on those block creating pools? And last but not least is, can I be censored? If some government or some group of miners decide that they don't want their competitors to be able to gain access to the blockchain, can they censor the blockchain? Can they prevent transactions from going through? Those are kind of the three criteria, and it's based on those three questions that you'll see different blockchains playing out. So, for example, with Bitcoin, the idea is today most people can't mine. You can join a mining pool. There are ways to do it. There are even ways to kind of get a mining as a service. But really, you don't really stand a chance to mine. And your hash rate as a personal kind of running your own server person is going to be very, 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 very minuscule. So in reality, you can't quite mine a block, but you can run a fully validating Bitcoin network node on your laptop and validate every node that comes in and see that everyone else is playing by the rules. More importantly, you can see when the rules get changed. So, and that's really important because those big mining pools can't change the rules on you and you would miss out. You wouldn't even notice that they've changed something. And last but not least, it's very censorship resistant. It's very hard to censor a transaction on the Bitcoin network because it's so widely distributed, because so many people can run their own nodes on their own computer, and the gossip protocol spreads out over the world to many, many different personal laptops, basically. So it's very hard to censor a transaction. And even if they did, there are always different channels. Like there's a Lightning network where if you can just open a channel with someone, those transactions are much more challenging to censor. So it's very censorship resistant, and it's very easy to run and validate the network on your own. So there's a high degree of trust, but you can't participate in the mining pool as much. Ethereum holds true by those two, very similar to Bitcoin. On a slightly less degree, it's hard to run your own node in Ethereum. So you're trusting professional nodes much more than in the Bitcoin network. And we've already discussed a lot of the work that's being done to get it to the point where you will be able to run your own node on your own laptop. But today, that's still harder. On the other hand, it is very censorship resistant because of the same ideas of Bitcoin. And the mining is more distributed than Bitcoin. And the idea is that proof of stake will also make that more distributed so that anyone can spin up a node with just 32 ETH or 16 ETH, or even now contribute to something like Lido Protocol or Rocket Pool and be part of those staking pools. And that's democratizing access to block production. So those are, one spectrum of the crypto world. Solana takes a different approach. And I'm going through this because I think it's important for understanding what matters in Vitalik's Endgame. But Solana takes a different approach where creating a block or validating the blockchain is much harder because you have to have a server set up in some networking location where you have high bandwidth and where you have relatively more compute than your laptop. So you actually need a dedicated server running somewhere, and that's going to validate the blockchain and also help produce blocks because it's a proof of stake network. So not everyone can do it. On the other hand, and this is what the Solana team says does make it censorship resistant and decentralized, is that it is very hard to censor, according to them. They have 2,000 nodes around the world. And so the odds are that it's hard to censor 2,000 nodes. And as long as someone has a valid record of the blockchain, then it's very hard to kind of destroy all existing copies. And so for Anatoly, the CEO of the Solana Foundation, is the founder of the protocol, when he talks about decentralization, that's what he's talking about. He's talking about censorship resistance, and he's talking about being able to destroy all copies of the ledger. He's not really referencing the fact that I need to verify every block on my own as a user to trust it. And that's less a focus for Solana. And so as a user, the risks are that if the validators, the people who are running the proof of stake chain that Solana is on, decide to change the rules, not only will you as a personal user not be able to do anything about it so much, you won't even know for a while because you don't run a fully validating node. You don't run the code. You're just submitting transactions to those people. So if they wanted to up the fees or add some kind of shady something, they could do it. And it would take a while for people to figure out. So that's a real risk of having these quote unquote fully centralized nodes, or at least as a user, you don't know what's going on. So those are the three kind of metrics: who validates, how centralized are they, who produces blocks and how centralized are they, and censorship resistance. And that is what Vitalik is talking about, because he cares about all of those things. And the end game, or what concerns him in the end game, is that we reach a point for Ethereum where there is centralized block production and centralized validation, kind of like Solana. And that happens in the event where we haven't created the tools to decentralize, to make running a node on your laptop easier. And that happens with sharding, that happens with data availability sampling, that happens with rollups, and kind of distributing the power of the network across a greater number of participants. Now, what is he concerned about specifically? And here there are a few things, because there is a tendency towards centralization in blockchain. In Bitcoin, there's this huge pushback against this, that proof of work leads to centralization. I don't really buy it. I think in any highly competitive industry where resources can be scarce, and resources here can be hardware, skills, or people, if anyone can manage to control enough of the value chain, there can be centralization. And with proof of work mining, that can be power consumption, that can be hardware, it can be all kinds of different things. In Ethereum, that can be expertise. It can be ETH as the proof of stake currency. Vitalik references MEV, minor or maximum extractable value, which is a concept of in every block, you can rearrange the blocks, or you can rearrange the transaction, so that you can create arbitrage based on what transaction occurs first. And maybe we'll go into this fully in a fully read through, because there's a great article called Flashbots that really dives into how do you do extractable value and what the risks are to the network. But really, you can think about it, if there's some whiz kids who figure out how to game the system, they're just generating more capital because they've done some high frequency trading, think about it that way, arbitrage, and they're just generating more and more capital faster than everyone else, and that compounds. And in a proof of stake network, that can definitely compound because it's capital and that's what matters. But that also can come into play in terms of hardware. And if there's a specifically uniquely talented team of DevOps who manage to create great block creators, they put up a company and this is what they do really, really well, they can get some edge, and they can be creating blocks for Polygon, for Arbitrum, for Optimism, for Ethereum. This is what Vitalik's talking about. And they can gain some edge and become the centralized player. This is also true in zero-knowledge proofs and snarks, that this technology is cutting edge. The companies who are developing it, there isn't that much competition. The first one to create a valid network around them, well, that's going to be a very powerful network effect, and they're going to gain a very big edge on the rest of the competition, just because it's a superior technology, vastly superior technology. And so there's a real concern that in the end game, we'll have this centralization factor. And so what Vitalik is thinking about is, great, even when you have that centralization factor, how do you deal with it? How do you make sure that individual users can still validate the blockchain and not have to trust those big block creators? How can we partake in being a censorship-resistant network so that if those centralized players don't want to allow certain transactions to go through, how can we still do it? And that's what this article is all about. And he runs through these two scenarios of a very dominant rollup chain and a very distributed ecosystem of rollups. And how does that each affect it? And what can the Ethereum ecosystem do to create a decentralized endgame for Ethereum, even when we reach kind of the quote-unquote promised land of the merge and roll-ups and sharding. Because even then we have this risk of decentralization. And we have to remember that decentralization is what matters. Because without that, nothing that we're building on the blockchain is inherently better than anything that we've built in Web 2 and in the centralized world. It's just a much slower version of it and not worthwhile. So decentralization is what matters, and that's why in the end game, we have to keep that focus front and center. I think reading this has made it clear to me that we have to dive into one of the classics of the Ethereum ecosystem, and an article really has become seminal in all of layer ones and blockchain in general, and it's called The Limits of Blockchain Scalability, also by Vitalik. So I think that's definitely going to be on the list of to reads soon, and maybe the Flashbots article as well, just because it gives a really, really good idea of what MEV is, the risks, and the opportunities.